The difference between matter and a substance is that matter is a more general term. It's anything that has mass and takes up space, whereas a substance is a single pure form of matter, so it is a type of matter. Two examples of a substance is a bar of gold that only contains pure gold atoms, and Au is the chemical name of gold, and a cup of water. The water only contains H2O, which is hydrogen and oxygen in a 2:1 ratio. And these are just molecules of water. Something that is matter but is not a substance is, for example, air. Air is made out of different gases, about 78% of nitrogen gas, 21% of oxygen gas, 0.93% of argon gas, and 0.04% of carbon dioxide gas. Next, let's talk about the three basic states of matter. I will use water as an example because it's the most common molecule that we see in our daily lives. The first state of matter is a solid state. This is the rigid form of matter. For the case of water, we know it as ice. At the macro scale, we see them as ice cubes. At the micro scale, we see water molecules that are tightly bound together. The second state is the liquid state, and this is a fluid form of matter, and it takes the shape of the container that it occupies. For this case, water is just a liquid and is contained in a piece of glass. At the microscale, the water molecules are more freed up compared to the solid state. The process to go from the solid to the liquid state is called melting. And we can think of this process at the microscale as the water molecules getting freed up by some source of heat. So heat has to be taken in during this process. The next state is the gas state, and this is a fluid form of matter that fills any vessel containing it. For the case of water, this is known as water vapor. And at the microscale, the molecules of water are the most free that they can be. The process to go from the liquid state to a gas state is called vaporization. And just like the previous case, we're freeing up the water molecules even more, so we need some source of heat taken in. To finish the cycle, going from the water vapor or the gas state to the solid state or the ice, we need a process called deposition. And in this case, the water molecules are going from the most free state to the most tightly bound state. So in this case, the heat is actually released or going out. Finally, let's complete the cycle in the opposite direction. Going from the solid state to the gas state, we need to do a process called sublimation. In this case, the water molecules are going from the most tightly bound state to the most free state. So there needs to be something to break up the bonds from the solid state to the gas state. For this, we need heat taken in. Then, we go from the gas state to the liquid state. And for this to happen, we need a process called condensation. In this case, we're going from the most free state to a more tightly bound state. So we need heat coming out. And then, going from the liquid state to the solid state, we do a process called freezing. And here, the liquid state to the solid state, the water molecules are getting more tightly bound together, so heat is also coming out. There are two different properties that we can differentiate in chemistry. The first one is physical properties, which is something that we can observe or measure without changing the identity of a substance. As an example, I can have a cup of water, and some things that I can say about this water is that it has a mass of 100 grams and is at a temperature of 25 degrees Celsius or room temperature. So these are descriptive things that I can say about the water without changing its nature. The second one is chemical property, which is the ability of a substance to be changed into another substance. As an example, I can say that I have hydrogen gas reacting with oxygen gas to form water in the form of gas. This is actually a quite reactive reaction that releases a lot of energy. This reaction is used in rocket propellers, and the water is actually released in the form of vapor that is at 10,000 miles per hour, which is energetic enough to propel the rockets. We can see that the hydrogen here and the oxygen are actually changing its nature completely into water and energy. So each chemical property is associated with a chemical reaction. Let's do one example. In the problem here, it says to classify the following properties as chemical or physical. For part A, objects made of silver become tarnished. We can have a silver spoon that later becomes tarnished. Tarnishing is just a layer of silver sulfide on the silver spoon that makes its color darken. This can be caused by the silver interacting with sulfur-containing gases, such as sulfur dioxide from pollutants in the air, or hydrogen sulfide from the interaction of the silver spoon with hard-boiled eggs. In the first case, we have a chemical reaction of silver with sulfur dioxide, forming silver sulfide and oxygen gas. In the second case, the silver is interacting with hydrogen sulfide and forming silver sulfide and hydrogen gas. In both of these cases, we can see that a chemical reaction is involved, so we can say that tarnishing is a chemical property. Even if we didn't know what chemical reaction exactly is going on, we see that the silver is changing its color. So there must be some chemical reaction that is making this to happen. For part B, we have the red color of rubies is due to the presence of chromium. Rubies are gemstones that are made out of aluminum oxides and chromium, and there is about 1% of chromium ions in there. So this sentence is just describing the nature of rubies. The aluminum oxide and the presence of chromiums is what makes ruby what it is. So this is just a physical property. For part C, it says that the boiling point of ethanol is 78 degrees Celsius. Ethanol at room temperature is in liquid state. And this statement is just saying that its boiling point, or in other words, the temperature at which it vaporizes or it turns into gas, will be at 78 degrees Celsius. This is not describing the actual chemical reaction, but is just stating that this is the temperature at which this ethanol liquid turns into vapor. So this is a physical property. Next, let's talk about size-dependent properties, or intensive versus extensive properties. Intensive properties are independent of the size or the amount of the sample. Some of these properties include the boiling point, color, temperature, luster, and hardness, among others. Extensive properties are dependent on the size of or the amount of the sample. Some of these include the volume, the mass, size, weight, and length. For example, we have a cup of water whose volume is 50 milliliters. The mass of this water is 50 grams. And let's say that this water is in a room whose temperature is 25 degrees Celsius. Therefore, the water is also at 25 degrees Celsius. We can define the density as the mass divided by the volume. For this case, it is 1 gram per milliliter. And this water will boil or turn into gas at 100 degrees Celsius. Now, let's say that we drink half of this water. Now the volume will be 25 milliliters. The mass is 25 grams. So both of these are half. The density, mass over volume, will still be 1 gram per milliliter. The temperature of the room has not changed, so the water temperature is still the same. Now, the boiling point of any water is 100 degrees Celsius, regardless of its size, whether I have 1 liter of water or 15 milliliters or 25 milliliters. So these properties are intensive properties, whereas these ones, volume and mass, are extensive properties, or size dependent. Let's do one more example problem regarding this topic of size-dependent properties. In the problem here, it says to state whether the following properties are extensive or intensive. For A, we have the temperature at which ice melts. So let's say I have a cube of ice, and I have another one which is twice its size. Regardless of the size, both of these ice cubes will melt at 0 degrees Celsius. So this is an intensive property. For B, the color of nickel chloride. So nickel, let's say we have it in powder, and I have 50 grams of this. This is yellow in appearance when it's free of water. Let's say I have 10 grams of this powder. This is still yellow regardless of how much nickel chloride I have. So this is also an intensive property. For C, the energy produced when gasoline burns. Let's say the tank of gasoline of my car is 50 gallons. And I have another car whose tank is 10 gallons. This one here will produce more energy and it will last me longer. And this one will produce less energy and will last less time. So this one is less energy compared to this one. So the energy produced when gasoline burns is an extensive property. For D, the cost of gasoline. So this obviously cost me more than paying for 10 gallons of gasoline. So this one is also an extensive property.